Hello everyone. In this video we're going to discuss sample preparation for water activity testing. Now sample preparation can cause a change in water activity if you change the way that you prepare your samples. So one of the most important keys to good sample preparation for water activity is to be consistent. Because what your goal is to try to make sure that your sample preparation is not introducing variation. And so consistency is really important. The other important thing is to protect your sample from the environment, because anytime that it's exposed to the environment, water activity, relative humidity are associated. So your sample will either take up moisture if it's below room humidity or lose if it's above room humidity. And so you want to minimize the amount of time that your sample would be exposed to the environment. So those are the main points to focus on in terms of sample preparation. Be consistent, protect it from the environment. But now let's talk about some specific types of samples and we'll show you how you would or how we would recommend that you prepare samples for these types of materials in a way that will give you the best results for water activity. For samples that easily fit into the sample cup, there really isn't a lot of sample preparation necessary. Here you can see the sample cup, and again our target is no more than half full. There's even a nice line there inside the cup that will give you an indication of about where you would want to fill your sample. And again, this is a intensive property. It doesn't matter how much, you don't need to weigh it, but you want to have enough in there so that it will dominate the headspace. There's no need to check every time whether or not you're putting the exact same amount of sample in. But for a sample such as honey, where it's a high viscosity sample, all you need to do is just basically squeeze some of it into the cup, keeping in mind that fill line. We close the sample up. And there we have our sample ready to run. We simply put it in the instrument, close the lid, and we're running our test. So very simple for that type of a product. Now, depending on what the viscosity is, what the sugar content is, will have some impact on the test time for that product, but fairly easy in terms of sample preparation.
Exactly. Good.
Next, if we had something like a crisp or a potato chip, here the challenge that we're faced with, of course, is that that chip won't fit inside the sample cup. So we're going to have to make it into smaller pieces. But in this case, it's just basically breaking up pieces of the chip. And you could do it from multiple chips so that you get some randomization to your testing. But basically, we're just trying to get enough pieces of the chip into the cup so that we can run a test on them. Now, one thing about something like a crisp or potato chip is that it can be quite greasy. So when you're touching them, you're getting grease on your fingers, and you want to avoid touching the outside of the cup with your greasy fingers. So you have something that you can wash your hands with, and then it's always a good idea to just kind of wipe around that cup to try to make sure you're not bringing fat into the instrument and that can get on the inside of the chamber. Got your sample, close the lid, run your test. Now these sample lids that are with the sample cups work pretty good as temporary storage, but they are not meant to be a long-term storage. So if you try to store anything in these for a long amount of time, like more than a couple of hours, they can start to have moisture that goes into the cup because it's not a perfect seal. You could put parafilm around it and that would seal it up better, but again, you don't want to use these sample cups as long-term storage. Now for a product like shelf-stable meat or beef jerky, here we have some small pieces, but still not quite small enough to get into the cup. For something like this, we simply would take some of those pieces and then we would cut them into smaller sections that will fit into the cup, avoiding hurting our fingers. And so then we can just fill the cup with those smaller pieces. Here again, these samples can be high fat, and so it's easy to get some fat contamination on the outside. Make sure that outside stays clean, and then we simply put it in and take a reading. Now with beef jerky, we do have a lot of situations where customers want to grind this particular product, and grinding is fine. It does introduce heat, which can drive off moisture, and so that can have slight altercations on the final water activity, but in most cases that exposure to the heat is very short, and so there's not a huge amount of water loss. And if we think back to our consistency, because what we want to detect is when changes in water activity occur that could be dangerous, then grinding with a product like this is actually okay as long as you have a consistent approach. And especially if you're preparing that sample for multiple tests, if you want to run NIR or something else with it, then it can be quite convenient to just run a grind on one of the samples and then subsample out of that. And that's fine, again, just as long as you're consistent. Our next sample would be a pet food. Now, pet food, in a lot of cases, are hard kibbles, and a lot of times it's a mixture of different types. Sometimes you might even have some soft bits within those kibbles where they're a little bit softer texture. And based on moisture migration, they should be at the same water activity, but you might want to test them even separately at times. And anytime that you have a product like this where you have multiple components within there, if you want an overall water activity, it's good to sample from each one of those components and try to have a amount that is representative of the amount of that material that's in the actual product. If you want to know whether or not the water activity of each of those components is the same, then you would separate them into their own individual component types and then take readings on those separately. And then compare the water activities to see if they're the same. If they're not the same, then there's a chance for moisture migration. Now, with this particular type of product, what I have found in my experience to be the easiest approach is just to do a crushing. If you put these in intact, and they probably would fit in the cup, but if you do that, they have a fat coating on them in most cases, and if you don't break apart that fat coating, in a lot of cases, you'll just take readings of the surface. Okay, so if we take a look at this type of product, the best thing that we can do, or the one that I would recommend the most, is just to do a simple crush on it. So once we have our sample in here, we're just going to do a light crush on it. We don't need to pulverize it into a full powder. We just want to get the size of those a little bit smaller and get the surfaces broken up. So once we've crushed that up, we can take a sample out of there. You can see now that we've got a crushed sample. Fits much easier into the cup. Notice that I haven't pulverized it into a powder or taken a really long time to do that. Again, the idea is just to break that surface, increase the surface area, and then that will make the test runs have less variability and it will run faster. Next, we have a snack candy bar where we've got multiple components within the candy bar. So here's another situation where we're going to need to cut through this candy bar. And if we take a look at the interface of that candy bar, you can see there's essentially 3 and maybe even 4 components within there. There's a chocolate coating, there's a marshmallow filling, and then there's a caramel section, and then a cookie section at the bottom. So if we were going to test this for water activity, we want to cut through all those components and try to have them representative in the actual sample that we take. So what that might look like is if we take our sample cup and we take one of our bars, we could just do a cut through the interface of that and then place that inside of our cup, and then can do that again. That way we're getting a mixture of all the different components. Now again, if you were going to or wanted to test to make sure that the components within here were the same water activity, then you would need to separate the components. And that's a messy job. It can be done, but it can be a messy job. So now you can see we have a representation of the multiple components within our sample. We do want to try and get that down a little bit lower so that we're not causing contamination on our top of our instrument. But then that would be ready to go. Place it in the instrument, take a reading. Let's take a look at another bar. Here we have a common protein bar where you've got some protein center to it, along with some nuts and then a chocolate coating. Again, here we're going to have multiple components. So if we were to cut through the center of that, notice that we have multi-components. We have nuts, we have a chocolate coating, and then we have an interior nougat that's going to have the protein in it. So again, in this situation, we need to get representative of each of the different components. If we wanted to run, again, the components individually, we would have to separate those out. So we'll take our sample cup and place our cross cuts with each of the components into our sample cup. We can break them apart too. They don't have to stay intact. And take a paper towel just to make sure we don't have any chocolate sitting up on the rim or on the outside. Now we have our sample. We would get a good representative reading on that sample type. Now our final sample type that we'll talk about are solid dosage tablets. So within the pharma industry, one of the most common forms that are measured for water activity are solid dosage tablets. So these are intact, obviously. If you read these intact, the surface, you'll get mostly a reading off of the surface. And so you want to, again, crush these so you can break apart that surface. That will help you get more consistent results as well as faster results. You don't want to spend a huge amount of time doing this because, again, all the time that it's exposed is time that it's having an impact from the humidity. But again, it's just a simple crush. And we take our cup. We can use a spoon, or we could dump it out of here, whatever works best. But what we're looking for is not pulverized to a powder, just into smaller pieces where we've broken apart that surface. So there you can see an example of what that would look like for reading. That increased surface area is going to make it equilibrate faster, as well as get better repeatability in our results. So there's some examples of ways that you can do sample preparation. Certainly if you have a product that you're not sure what to do with sample preparation, the best thing is to just contact your local distributor or contact us here at Novasina. We would be happy to work with you on the best practices for sample preparation for your particular product. But the key again is be consistent. Whatever you decide to do, just be consistent in that so that you're not introducing variation, and to prevent your samples from having long-term exposure to your room that could cause changes in the water activity. And good luck with your testing, and thank you.